Hello everybody. In this video, we will discuss elaborately about the armature reaction process. So you consider this diagram. So in this diagram, the field coils are excited. The flux lines are passing from north pole to south pole about its symmetrical axis, right? So here the armature current is not flowing in this diagram, hence there is no armature current, there is no armature flux. Here for simplicity, so only two pole generator is considered here, and if you are observing this diagram, you can find the brushes are directly touching the armature, but in actual case the brushes are touching only the commutator segment, not the armature. Okay, if you are observing this diagram, you see about its magnetic neutral axis. Magnetic neutral axis is nothing but the axis where the EMF induced in the armature is 0. So here the magnetic neutral axis and the geometric neutral axis both are coincides, right? So in the magnetic neutral axis, with respect to magnetic neutral axis, some conductors are under the influence of north pole, and some other conductors or otherwise you can say the remaining conductors are under the influence of south pole, right? So here in this diagram, if you are observing this, so the flux distribution is uniform. The flux lines are passing from north pole to south pole, and the this flux, so the MMF produced due to this flux, MMF is nothing but the number of turns into the current passing through the number of turns, right? So that is called as MMF. Here the MMF produced due to this field magnet is shown as OFM, the vector OFM, which represents direction as well as the magnitude of this magnetic flux, which is perpendicular to the magnetic neutral axis. So this is the thing you have to observe from this diagram. In this diagram, the field magnets are not excited, only the armature is excited. So it is like the load is connected to the armature, then the current will be flowing. So if the current is flowing through the armature, then it sets up its own flux. So that alone is shown in this diagram. You see this here. Here two north pole, the conductors under the influence of north pole producing the magnetic flux which is in one direction, and another flux which is set up by the conductors under the influence of south pole, so that produces another flux. If you want to find out the direction of current flowing through the armature, you can apply Fleming's right hand rule and you can find out the direction of this current flowing through the armature. Then these two armature fluxes produces MMF, so which is in the direction of that is in the magnetic neutral axis, the vector OFA. So that represents magnitude and direction of this armature MMF produced by this armature flux. But in actual case, so like field and armature will not be separated. So both these fluxes are there in the DC generator. Both are acting simultaneously. So that we will see it in the next diagram. Okay, you observe these two diagrams. So here the first diagram shows the field magnet flux and the armature flux. So both are acting simultaneously. If these two are acting simultaneously, let us see what are all the action takes place in the DC generator. You see here, if you are seeing the previous cases, the fluxes are not distorted, it is uniform, and it is symmetrical about its magnetic neutral axis. But in this case, it is not like that. So what will happen? These two MMF, that vectors OFM so which is produced by the field magnets, and OFA, which is produced by this armature magnetic flux. So these two are vectorically added so that we are getting the resultant vector OF, so which is shown in the diagram. So always this MMF, the resultant MMF is perpendicular to the magnetic neutral axis. So due to that, due to this resultant, so the magnetic neutral axis is shifted by the angle theta with reference to geometrical neutral axis. So due to the shifting of this magnetic neutral axis, the conductors which are under the north pole, under the influence of north pole, are moving towards south pole, and it's vice versa, right? So because of this, what will happen? So the flux distribution in the air gap between the armature and the field coils are not uniform, and the fluxes are distorted. Then if you are observing the second diagram, you see the flux density is not similar in all the poles, that is entire area of the poles. Generally, so the trailing poles are heavily crowded by the magnetic flux, and the leading poles are lightly crowded by the magnetic poles. That is shown in the next diagram. So the magnetic neutral axis is shifted with geometrical neutral axis by angle theta. Now the fluxes are crowded in the trailing pole tips, and it is not crowded in the leading pole tips. Here, so this armature MMF FA is divided into two components. One is FD and another one is FC. So here this FD is called as demagnetizing component, and FC is called as cross magnetizing component. So this demagnetizing component will reduce the flux available in the DC generator. Hence it reduces the EMF induced in the DC generator, since it is directly proportional to the magnetic flux. And the next component FC, which is called cross magnetizing component, which will distort the magnetic flux in the air gap between the armature and the field coils. So due to this this unevenly distributed magnetic flux, so and the shifting of this magnetic neutral axis, the sparking takes place between the commutator segments and the brushes. So that is the cause of this cross magnetizing component. An animation video is shown for this armature reaction. Please observe. All these processes are associated with this video. Previously only this magnetic fluxes are there. Now only this armature fluxes. Now these two are combined. Now the magnetic neutral axis is shifted, and the sparking takes place between the brushes, and the fluxes are distorted. So here some methods are shown to avoid this armature reaction, so that we will discuss it in the next video.